A spontaneous process, also known as a thermodynamically favored process, proceeds on its own once it's started, given the conditions that are available and without any additional assistance. So this definition is different than what you are used to. Perhaps you've heard of spontaneous combustion, in which a person walking about might suddenly catch fire. That definition of spontaneous means it all just starts for no reason, but our definition of spontaneous, thermodynamically favored, is that it proceeds on its own once we get it started. So once it's started, it'll keep going. So, as an example, water will spontaneously run down a hill. It spontaneously goes down. Sugar will spontaneously dissolve in coffee if you put it in the bottom of the cup. Iron will rust. Water freezes below 0 degrees Celsius. That is spontaneous if you have that condition, if you are below 0 degrees Celsius. However, if you're above 0 degrees Celsius, water will melt spontaneously. The reaction that occurs spontaneously depends upon the temperature and other conditions present. Heat will flow from hot objects to cold objects, and gas will expand in an evacuated bulb. As an example here, we have, if you had one bulb filled with gas and it's sealed off from another bulb which has no gas, spontaneously that gas will spread out. This reaction going to the right is spontaneous, that's thermodynamically favored, and going to the left, that's non-spontaneous. You could make this turn into that, but you'd have to do a little bit of work to make that happen. So perhaps by pushing this in, or by creating some suction on this side. Non-spontaneous reactions can occur, but with the addition of work. Whereas spontaneous reactions can often do work and cause other reactions to occur. So what makes a process spontaneous? The answer is, it increases the disorder or entropy of the universe. As an example here, this reaction, going from here to here, it occurs spontaneously to the right because it spreads your compounds out. They're more disordered. They're moving about more randomly. They're further from each other. We'll talk more about entropy later, but this is the key, kind of the key thing which is mentioned in the second law of thermodynamics. The entropy of the universe increases in spontaneous processes and remains unchanged in an equilibrium process. Or, we could say, every reaction that occurs increases the entropy of the universe if it's occurring spontaneously. So any reaction that is occurring significantly increases the entropy of the universe. Now this might be bad news, because what happens to the entropy of the universe over time? If spontaneous reactions are occurring, over time the entropy of the universe is going up. Until at some point, though, we can assume that we're going to get to some maximum point of entropy, at which point entropy of the universe can no longer be increased. And when that happens, when no spontaneous reactions can occur anymore because we cannot increase the entropy of the universe, then we would have had the heat death of the universe, where no spontaneous reactions can occur, so or living beings which require these spontaneous reactions, such as the combustion of glucose within our body, and metabolism, those reactions cannot occur, and so the living organisms would not be able to exist either. Heat death of the universe. Heat death of the universe, which is dependent upon this second law of thermodynamics, which is really all that this chapter will be about. All right, thanks for watching, guys.